Next is Saytzeff Rule. Saytzeff Rule is a rule made by a Russian scientist to explain the products formed by even reaction. Whenever we talk about even always go through SN1, even always go through Saytzeff Rule, or always follow Saytzeff Rule. So what exactly is Saytzeff Rule? Just write down. When a small base abstracts beta hydrogen from the carbon chain, the alkene formed is more alkylated alkene. In other words, whenever the removal of hydrogen will take place, it will always take place from that carbon which is more branched. Okay, so let me just explain you this with the help of an example. Let's say I have this as a molecule. Now when even reaction will take place, this X will be removed first and it will form a carbocation, RCH2, CH plus and CH3. Now this is my beta carbon and this is also my beta carbon. Let's say this is beta 1 and this is beta 2. So what will happen when the base will attack? Now this is not a symmetric molecule as before we had taken in the example. So when the base will attack, it has two options. It can attack on this carbon's hydrogen also, and it can attack on this carbon's hydrogen also. But which one it will opt for attacking? According to the Saytzeff rule, it will go or it will abstract the hydrogen from the more alkylated carbon, or it will form the more alkylated alkene. Which one seems to be more alkylated? This CH3 or this CH2? This carbon, this beta 1 is more alkylated. More alkylated means more branches over here. More alkylated than B2. Alkylated means more branches. Okay, so in that case, rather than removing hydrogen from beta 2, it will remove the hydrogen from beta 1, and hence the product form would be RC. So removal of this hydrogen will take place, and the product would be RCH double bond CH CH3. This will be my major product. Whereas the removal from beta 2 may also form, but that will be in very less quantities, and hence the product formed by removal of hydrogen over here will be RCH2 CH double bond CH3, and this will be in CH2, and this will be in minor quantities. So this product, which has formed by removal of hydrogen from the more alkylated carbon, will give you more alkylated alkene. And if you look at this alkene, this is more stable alkene also. We already know how to check the stability of an alkene by checking the hyperconjugating structures for that alkene. It has more hyperconjugating structures as compared to this. So this is more stable alkene, and this product is called as Saytzeff product. Whereas the other product, which is formed in the minor quantities, is called as Hofmann product, and got discovered by Hofmann. And this is the less alkylated alkene. So both will be forming. One will be forming in major quantities, another will be forming in the minor quantities. This kind of reaction is called as Regioselective reaction. So what do we mean by regioselective reaction? Regioselective reaction means where the reaction in which specific region is fixed that the elimination will happen or the reaction will happen at that specific region and will give you specific type of product more than the other. That kind of reaction is called as regioselective reaction. So write down the reaction in which structural isomeric products are formed in uneven quantities. The reaction is called regioselective reaction. Regioselective reaction. Now we'll see some examples of how to solve the question using the Saytzeff rule and the general even mechanism what we have learned. Let's try out some examples now. Now let's understand Saytzeff rule with the help of some examples. That's it. We have taken this as an example. This bromine is acting as a leaving group over here. Now, even before our this particular reagent act as a nucleophile or a base, this molecule will leave its leaving group and will get converted into respective carbocation. So the molecule will become CH3, 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 CH2 plus. Now what kind of carbocation we have got? We have got a primary carbocation now. So it will rearrange itself. It will rearrange itself to become a better carbocation. And it will become CH3. So what kind of shifting will happen? The CH3 will shift over here and this plus charge will shift over there. So it will be 1,2 methyl shift. So this will become CCH3, CH3, CH2, CH3. Now we have got a tertiary carbocation. The stable one. Now this MeOH will attack on it, and it can attack through two ways. We have already discussed about it. One through an SN1 pathway and second is through even pathway. So it will have two products possible. One is through SN1. MeOH will attack on this carbon and will give you CH3, CCH3, OMe plus H, CH2, CH3, which will eventually lose its hydrogen. It will lose its hydrogen minus H plus and will become an ether. This is one product which is possible. This is our SN1 product. Another set of products will be possible with the help of even. So now in case of even, rather than MeOH attacking on this positive charge, we have two options. Let's see how even will take place. CH3, C, CH3, C, I can write this CH2 as CHH. This is my beta hydrogen. Oh, so this is my beta carbon. This is my beta hydrogen. Another beta hydrogen, I have it on the adjacent position here. So this CH3 can also be written as CH2 hydrogen, C plus, CH3, CH2 and CH3. Now when MeOH will attack, it can pull out this hydrogen or it can pull out this hydrogen. If it will pull out this hydrogen, if this base will pull out this hydrogen, the product form would be the product form would be an alkene with a double bond over here. So the product will be CH3, C double bond CH, CH3, CH3. And if the hydrogen will be removed from this site, the double bond will be formed over here, and the product would be CH2 double bond C, CH3, CH2, CH3. Now we have to understand, according to the Saytzeff rule, what we have learned when a small base comes and attack on the carbocation, it will abstract the hydrogen which is attached on the more hindered carbon or more alkylated carbon. So which carbon is more alkylated over here? Let's mark it beta 2 and beta 1. So beta 2 is more alkylated or beta 1? Or beta 2 is more alkylated, and hence this product will be called as Saytzeff product. And this product will be in major quantities. And removal of hydrogen from beta 1, this is the less alkylated carbon, and hence this product will be called as Hofmann product. And this product will be in minor quantities. So this is how we apply the Saytzeff rule. So if you will be asked which of the elimination product will be major, this elimination product will be major. So in most of the cases they will explicitly mention, or the temperature or the conditions would be very clearly mentioned whether the reaction is going through SN1 in major form or even in the major form. And in that case, if it is going through elimination, you have to specifically mention which product is major, and in most of the scenarios Saytzeff will be major. There will be some cases where Hofmann can also be major. We will discuss that later, but right now, according to the Saytzeff rule, we take a small base, it will always attack on the carbon which is more alkylated one, will abstract hydrogen from there and will give that product in the major quantities. We will discuss about the Hofmann product later, in which all cases we will have this product major. Let's solve another example. So this is a second degree alkyl halide. And this reagent can act as a nucleophile or a base. Now even before this will attack, first of all chlorine will leave the molecule and will form a carbocation. So the carbocation will look like this. This will leave and this will form a carbocation like this. This carbocation is a secondary carbocation, but can this rearrange itself? Yes, it can, because it wants to make a better stable product, and it will do the ring expansion. It will form a 6-membered ring so that it can be much more stable than the current state. So let's mark the carbons 1, 2, 3, 4, 5, 6 and 7. Now what will happen? The bond between 5th carbon and the 6th carbon will form, and the bond between 1st carbon and 5th carbon will break, and this will shift, plus charge will shift on the 1st carbon. So the ring will look like this. So let's number it: 1, 2, 3, 4, 5 and 6. So on the 6th carbon we have an alkyl chain. This is my alkyl chain, and on the 1st carbon we have shifted a plus charge. So there is a plus charge over here. This is how my chain will look like. Now MeOH will attack, and again, as we have already discussed, 2 types of products are possible. One is SN1 product and another is even product. So when the SN1 reaction will happen, in that case this oxygen lone pairs will attack on this positive charge, will try to form a bond over here. So this will attack over here, will form a bond with the carbocation, and the molecule will look like this. OMe H plus. Bond between oxygen and hydrogen will break and it will form OMe, ether. Fine. Now when we are talking about even, rather than even attacking on this positively charged species or carbocation, it will attack on the hydrogens. It will abstract the hydrogen from the beta position. So what all are the beta positions? This is the beta position and this is the beta position. Let's mark it beta 1 and beta 2. Now I'll write down the hydrogens, I'll mention the hydrogens explicitly over here. So this is one hydrogen here, and this is the hydrogen over here. Okay, so what MEOH can do? MEOH can either pull out this hydrogen or can pull out this hydrogen. So if it will pull out the hydrogen from beta 1 position, the product form would be double bond between this carbon and beta 1. This will be the product formed, okay? And this is when removal of hydrogen has taken place from beta 1 position. Now, other cases, it can remove the hydrogen from here. Your MEOH can remove the hydrogen from here. If hydrogen will be removed from beta 2 position, the compound will look like this. Now, which one is more favorable? As according to the Saytzeff rule, we have already discussed this, that the more alkylated carbon will lose its hydrogen. So this beta 1 position is more alkylated, and this will be our Saytzeff product. And this will be the major product. Whereas the other one from beta 2 position where the hydrogen has removed, that is a less alkylated carbon and hence is a Hoffman product. And will be in minor quantities. I hope now you must have understood how to solve a question and how to get a major product if the elimination is happening. If the question has been given that tell the most favorable product formed in this elimination reaction or which product will be the major, you should be able to identify which will be the major one, or you should be able to solve and get the right answer. Now I'll write down some questions, try them out, and then we will discuss, we will find out which product is forming in the major quantities, which is forming in the minor quantities.